Hello and welcome to the section 1.2 lecture today. Today we're talking about solving two-step equations. So yesterday we talked about one-step equations. Today we're going to add a step to each one of those equations. So one more thing happening to the variable. That's what's going to cause another step when we're solving. So yesterday we talked briefly about what inverse operations are. Today we're going to do it a little more in a table environment. When we're looking at an operation and the problem has addition, we want to think of its inverse as subtraction. If a problem has subtraction, we want to think about solving it using addition. If it has multiplication, we would like to divide. Let's say division. And if a problem has division, we want to solve that using multiplication. So not only are we using the opposite operations, but we also, when a problem has two or more steps, we want to use those inverse operations in the reverse order. So when we're saying the reverse order, our normal order of operations is PEMDAS, parentheses, exponents, multiplication and division, and addition and subtraction. We want to solve it. So this is when we're evaluating, when we know all the numbers. Okay, in this order we know all the numbers. When we have unknowns and we want to solve for one of the numbers, when we don't know the equals side, or when we know the equals side and we have a missing number, we want to apply the inverse order of operations. And so we deal with kind of SAD map. But just as when we solved an equation, or when we evaluate, when we want to know what a certain group of numbers equals, following order of operations, you kind of do multiplication and division at the same time, and you kind of do addition and subtraction at the same time. We're going to follow that same idea that we're going to kind of do subtraction and addition at the same time, and we're going to kind of do multiplication and division at the same time. Okay. Parentheses and exponents will always come last. Okay. So let's look at how that's going to work. Whenever I'm looking at these problems, I always think about if I knew what the unknown value was, if I knew what the variable was, what order of operations would I follow? If I knew instead of x here it was like a 10, and I wanted to solve that, I would divide 10 by 2, and then I would add 3. Now that's obviously not equal to 19, so x obviously isn't 10. But knowing that process tells me the exact order that I want to solve it in. I want to do it in the backwards order. So in my mind, I'm thinking about stripping things away from the x, starting as far away from it as I can. And when I'm talking about as far away from it, I'm really talking about if I knew what x was, I would do this, and then I would do this, and then I would do this. I'm going to start with that last thing that I would do. I'm going to take that away. Then I'm going to look at the next last thing that I would do, and I'm going to take that away. And then hopefully by that time I'm at the x, and I'm good to go. So in the solving sense, in this one, I know that I would divide first and then I would add. So I'm going to deal with that addition. I'm going to move that 3 to the other side. I do that using addition and subtraction. And in this case, it's showing me addition, so I'm going to subtract. So I'm going to have x over 2 still. That's going to equal 19 minus 3, which is 16. Now I'm going to deal with this division. X is being divided by 2. I want to undo that using multiplication. And more importantly, I guess before I write those, right now it's a problem that I saw yesterday. Solving equations is all about make the problem one step easier and see if it's something that you did a day before or even a problem before, right? I took something that had 2 steps and now it only has 1 step. I feel more confident solving this. I undo dividing by 2 by multiplying by 2. Those 2's cancel, and I get x is equal to 16 times 2, which is 32. For my next one here, I've got some decimals that I'm dealing with, but that's no big deal. And again, I think about if I know what x is, if I knew that x was 10, I kind of always use 10. It's a pretty good number. If I knew that x was 10, I would divide, and then I would add. I want to undo those in the opposite order. So I want to deal with this 3.2. I want to move that to the other side. I'm going to subtract 3.2. Whatever I do on one side, I have to do to the other. So over here, those cancel. And I'm going to be left with, on this side, x over 2.5. And over here, 4.6 minus 3.2. If you have to use a calculator, please do so. But that's going to be, it looks like 1.4. Okay. Now I deal with this division. I want to undo the division. I undo division with multiplication. I'm going to multiply by 2.5 on both sides. Might be best to use a calculator at this point. 1.4 times 2.5, and we get 3.5. And that's my answer. Okay. I would like it if you'd throw a box around your answers, just so we know where our problem ends. And then keep in mind, when I'm solving equations, I can always go back and check. I can say, well, x is supposed to be 3.5. Let's test that. 3.5 divided by 2.5 is 1.4. If I add that to 3.2, I get 4.6. I didn't show any of that checking work, but I can do it. I can always go back and check my answer. Even if we look at the first one, that was 32 divided by 2 is 16 plus 3, 19. There we go. Okay, if you want to check it, I don't require that we check work, but it would be nice sometimes, right? It's nice to know that what you're doing works out. That's why, me personally, I love solving equations. Okay. So again, let's look at this one. Let's think if we knew that x was 10. I would multiply it by 3, and then I would add 5. So I'm going to undo those in the reverse order. So I'm undoing adding 5, undoing that to both sides. 3x is going to be equal to negative 15. That's negative 10 minus 5. And now it's a problem that I saw yesterday. 3 times x, I want to undo that multiplication, undo that multiplication. So x is going to be equal to negative 5. And just to kind of talk through it, negative 5 times 3 is negative 15. Negative 15 plus 5 is negative 10. It works out. Okay. These problems are just to show you that the variable can be in different locations. Okay. But this is a problem that's very similar to the one right above it. If I knew what n was, I would divide it by 2, then I would add 9. I want to undo those in the reverse order. Let's subtract 9 first. Over here they cancel, and over here I get 12 minus 9, which is 3, and I get n over 2. N is being divided by 2, so I'll undo that with multiplication. Those cancel. I get n is equal to 6. If you ever want to switch this around, you always can. You could always write this as n over 2 plus 9 is equal to 12. You can always flip things around the equal sign, whether it's addition, subtraction, any of that, anything happening in the problem, as long as you keep the order of the problem side the same. Notice this said n over 2 plus 9. I can always switch that around. And since it's addition, I could even switch the n divided by 2 and the 9. I could switch those if I wanted to. Okay? And even to check that, 6 divided by 2 is 3. 3 plus 9 is 12. It works out. The next one, if I knew what g was, and this is where doing this idea makes this actually an easier problem than maybe what you would think to do right away. Some people see a number outside of parentheses and they think, I'm going to distribute this. I'm going to say you don't have to. So if I knew what g was, I would add it to -3, and then I would multiply it by 10. Okay, I'm going to undo those in the reverse order. This one gets a little bit tricky because technically I'm adding a negative number. Adding a negative number is actually the same as subtracting. But in the short version, I want to move a -3. I move a -3 by adding 3 to both sides. Sorry, reverse order. Reverse order. We'll get to that. I would add -3 and then I would multiply by 10. I want to undo that multiplying by 10 first. I almost made a big oopsie. I got so caught up with the -3. And that's going to equal -3. -30 divided by 10 is -3. And this is where, again, some of your logic can definitely help you out and think -3 plus some number has to equal -3. What is that some number? That's a tricky one. Okay, but knowing the steps are going to help you in the long run in times that you can't do this really easily. Because whether the numbers are big or weird decimals, things like that. So here we have, I want to undo that -3 now. I want to move that -3 to the other side. I do that with addition, and here we go. Over here they cancel. Sorry, forgot to box in my answer. Over here they cancel, and I get g is equal to -3 plus 3, 0. And that works out with our idea of, that -3 plus a number equals -3. Well, that number can only be 0. And it actually would work out up here too, but it was a little bit tougher to tell. But 0 plus -3 is -3. -3 times 10 is -30. Last one on this side. If I knew what w was, I would subtract 1, and then I would divide it by 7. So I'll undo that division first, and this is definitely a different order than some of the other problems that we've seen. But we can cancel out those 7s. We get w minus 1 is equal to 1 times 7, which is 7. And now I want to take care of that -1 by adding 1. Those cancel, and I get w is equal to 8. And just to check it, 8 minus 1 is 7. 7 divided by 7 is equal to 1. So that works out. Sometimes we got to do a little bit more work. We got to do some simplification of one of the sides before we end up solving it. So when you're combining things on one side, you just want to follow your normal order of operations. But when I have one variable, I should be able to get to one of two kind of looks. I should either be able to get to like something, a variable, plus or minus something equals something, right? I should be able to get to that. And in all these, I can get to that. And it would actually make life easier if I do that first. Because we get really good at this kind of equation when we're talking about these two-step equations. So on this one, I have a -14 and a +4. I can combine those first and say 2x, that's going to be a negative 10 equals 10. Now it's like a problem I've seen before. It's a pretty straightforward two-step equation. I'm going to add 10 to both sides. And I get 2x is equal to 20. Because they cancel out over here, and 10 plus 10 is 20. Then I'm going to divide by 2. Divide by 2. X is equal to 10. All that work, and we got right back to a 10. It's all good. Over here, I've got a 2j and a negative 4j. I can combine those first, and I should combine those first. 2 minus 4 is negative 2. Those are my j's. Plus 10 is equal to 12. I subtract 10 on both sides. Now I'm just following my two-step equation rules. 2j is going to equal 2. Divide by negative 2. Divide by negative 2. 2 divided by negative 2 is going to equal negative 1. My next one, oh boy, is this a mess. It really is. I've got 2 things on this side with x's and 2 things with just numbers. Now, granted, those are all fractions, and we're going to have some work to do. There's actually a couple steps that I could follow here. One of them would be to get rid of all my fractions, and I'm sure you've gone over that before. This one isn't actually nice to do that. Because so many of the fractions are similar, it's actually more work to get rid of all your fractions. I'm going to kind of logic some of my way through this. With my x's, I have 1/2 minus 1/4. Sure, I could go find common denominators and say that this is 2/4 minus 1/4, or just think if I take a fourth away from a half, I'm going to end up with a 1/4. So I have 1/4 x, and then I have 3/5 minus 1/10. Here I am going to kind of think of this as 6/10, but that's actually going to make my life a lot easier. 6/10 minus 1/10 is 5/10, and 5/10 is 1/2. And maybe that's not the easiest way to do that. Maybe we leave that as 5/10, just looking ahead. I am kind of cheating a little bit. I'm going to leave that as 5/10 because I know that I have to combine that with this 7/10 over here. And it's just going to be easier. Because now I want to subtract my 5/10. Subtract my 5/10. And I get 1/4 x is equal to 7/10 minus 5/10, which is 2/10. And maybe we like that better as 1/5. Now I would say that we probably do. Okay. Here I want to divide by 1/4. That's really the same as multiplying by the reciprocal. My 4's cancel, my 1's cancel. That tells me that x is equal to 1 times 4, which is 4. 5 times 1 is 5. That was a lot of work for just 4/5 being the answer. And I think these are, oh, we have a little application at the end. Okay. I want you to pause the video here and try these 3 problems. Hopefully you had a chance to do that, and how you approach them could be different based on what you see. This one, I could see doing a couple different ways. I'm actually going to distribute this one first and then solve it. Sorry. So I have -4 plus 8m plus 56 is equal to 116. I'm going to combine my negative 4 and my positive 56. 8m is going to be plus 52 is equal to 116. If I subtract 52 on both sides, I'm actually going to grab a calculator for that just to check. I get 64. 8m is equal to 64. And I'll divide by 8. And I get m is equal 8. On the next one, I'll do the same thing. I'll distribute first. I'm distributing, throat's drying out a little bit. Too much talking. That's because the video got over 20 minutes. I'm distributing a negative 4. I get negative 16. Then I get a negative 16p minus 7. I'll combine the negative 7 and the negative 16. Going to give me a negative 23. And now I just want to follow my two steps. Undo the negative 23. And just to check that, that's going to be a negative 135 plus 23. So negative 112 is going to equal negative 16p. Here's a trick I do on my calculator. I know that a negative divided by a negative is going to be a positive. So I just divide the positive versions. And I'm going to get 7. Oops. So divided by negative 16 on both sides, I'm going to get 7 is equal to p. The last one, I'm actually going to not distribute first. I'm going to divide this by negative 7 first. And when I do that, I think I know what I get. They're both negatives, so when I divide them, they'll be positive. You get 17. 4n plus 1 is equal to 17. Subtract 1 on both sides. 4n equals 16, and we'll divide by 4. N is equal to 4. Pretty big numbers in a problem for n to just equal 4, but it works out. This one says, write and solve the equation described. Negative 1 is 8 more than 3 times a number. Let's piece this together. The key here is that the is going to be our equal sign. But this question says negative 1 is 8 more than 3 times a number. That's 3 times a number and then 8 more than that. Now that I have my equation, I can solve it. We get negative 9 there, 3n there, divide by 3. And n will equal negative 3. Okay, but when we have to write the equation first, it's always good to read it once and kind of think what it's saying. Notice I didn't exactly write it in the order that it said it, because it just made more sense to me to say 3 times a number and then add 8. Okay, so I hope that helps. Make sure you write down any questions and ask those when you get to class. Otherwise, have a good day, and we will see you then.